Those are stark warnings of what happens when terrorists succeed in getting an explosive or incendiary device on board aircraft, ships or channel tunnel trains. And we should even consider left luggage offices. Which is why it's so important that you are able to recognise these devices and their component parts when you're screening or searching baggage, searching passengers or searching aircraft and buildings. And because these devices come in so many different shapes and sizes, they can be concealed in an almost unlimited variety of disguises, so detecting them can often be no easy matter. And the aim of this video is to help you to do this more effectively. I've come here to Cranfield University at the Royal Military College of Science, which is part of the Defence Academy of the United Kingdom, to look at explosive devices and their components. Now, all explosive devices consist of 4 basic elements: explosives, detonators, switches and power sources. Now, these are time delay switches, I understand. I mean, a lot of them look like clocks, fairly obviously, but a lot don't. Take us through some of those.
Well, there's a whole selection here, Peter, and we have an electromechanical switch there, a straightforward kitchen timer that's been modified there, some memo park timers, 1 and 2 hour delay, and the modification there. As you mentioned, clocks, but you can also adapt watches and 2 different types there. Some electronic long delay timers and the solder wire close peg delay. The ones in the front there are actually mechanical time pencils and chemical time pencils, both from military use.
And what do they do?
The mechanical time pencil is a silent delay and works on a cocked striker principle.
Now, I understand this is a range of victim-operated switches. Can you explain what that means?
Yeah, that's correct, Peter. These are victim-operated switches, and we have a small selection here from release switches to pressure switches to a combination of both using this micro switch to a light-sensitive device there and barometric switches there.
So it simply means that the victim is the cause of the switch triggering?
Correct. The victim has to do something for the device to activate.
OK, how do these work then?
Well, if we take a typical example of this mouse strap, if I set it up by flipping over the flyover lever, if we place an object on top of that and somebody picks up the object, then obviously the pressure of the mouse trap will make the contacts come together.
Right.
This is a mock-up of the Mardi Gras bombers, and we can see he's modified this door bolt in that as soon as you open the lid, the elastic bands force the modified door bolts forward to strike the percussion cap at the base of that shotgun cartridge and initiate the device. On the pressure mat system, all we're basically doing is placing pressure on the mat, and the 2 foil contacts separated by this hold sponge come together to complete the circuit. As I mentioned earlier, these micro switches are ideal for both pressure and release switches, depending how we wire up the circuit. We can use it as a pressure switch or as a release switch. As regards the light sensitive, we're utilising this small photoconductive cell to initiate the device as we allow light to enter the box. And the barometric switches, if we use this homemade one in a metal tobacco tin, there's a small cardboard flap with a small piece of solder on the top there. There's a balloon inside, and obviously as the aircraft rises, the air in the balloon will expand the balloon to push up the cardboard flap until that small blob of solder makes contact with the inside metal tin. There is one other type of switch, and that's the command initiated. There are 2 types. One type I've got on the table there for demonstration purposes, which is the remote control. I've connected up the receiver to a small match head, which should flash when I initiate the device using the transmitter.
And what kind of range could that have?
I know we're demonstrating it in a fairly close confines of the classroom, but you can have a range of quite some considerable distance.
OK, let's see it go. Now, clearly, every explosive device needs a power source of some kind, and here we have a whole lot of batteries that are very familiar from any shop in the high street, but there are 1 or 2 unusual ones, aren't there?
There certainly is. The most common ones, as you said, would probably be the PP3s and the AA batteries. But we have others, like the button battery, the Alka-Seltzer size battery, and the Polaroid cassette battery, which is, as you can see, is nice and thin and ideal for letter type devices or for secreting into small areas.
In order to initiate the explosive, the bomber needs a component known as an initiator. Some for low explosives, like these on the left-hand side of the table, and some for high explosives, similar to these on the right. They consist of either commercially made components or indeed components that can be improvised at home. Looking down the left-hand side of the table, we see a number of familiar components, everyday items which can be used for this purpose. Here we have a gas lighter element. Here a modified torch bulb. Additionally, we have a photo flash bulb. And at the top end of the range here, we have an item known as a theatrical maroon. A small electrically initiated match head is a very suitable way of initiating low explosives, while other more familiar components like party poppers or indeed groups of matches will equally achieve the bomber's objective of initiating the explosive reliably. In terms of high explosive, we have a commercial component known as the detonator. Two examples or types of detonator are shown here. The plain detonator, so called because it is plain and open at one end, into which we fit a piece of burning or safety fuse. Or the electric detonator performs exactly the same function as the plain detonator, but is initiated by the activation of an electrical fuse wire.
What we're going to do is burn identical weights of gunpowder. The weight that we're burning is 25 grams. To visualise 25 grams of gunpowder, it's about half the volume of a golf ball, and you'll see the effect of gunpowder burning without any confinement. That's just an open-topped steel tube. What we're going to do now is just demonstrate the difference that an identical grade of gunpowder, an identical weight, 25 grams again, has just with a small amount of confinement. And this confinement is just a rubber stopper pressed into the top of the steel tube. Another use for gunpowder as a burning explosive, which is still current, is in burning fuse. And this is stuff that is used militarily and commercially to give us a burning time delay. One thing that is utterly futile to do is try and stamp that out. Also, it's pointless throwing water on it or even completely submerging it underwater because it doesn't need atmospheric oxygen. Once burning, it's going to burn quite happily, even completely submerged underwater. Next thing we're going to do is burn what's arguably the most commonly improvised homemade explosive mixture. And that's a mixture of sodium chlorate, which is most commonly encountered as a weed killer, and sugar. So it's very easily obtainable ingredients. So what we've got is about 100 grams of a sodium chlorate and sugar incendiary mixture. Animal rights extremist groups like to use this stuff and use it in sort of kilogram bulk. What we're going to do now is to look at a material that is similar to napalm. And what it is petrol that we've gelled using soap flakes. The advantage that gelling it gives the perpetrator is that, well, the most obvious one is it causes it to stick to the target. You can see it sticking to that vertical steel sheet. But the other advantage, and one that's less obvious, is that it's actually slowing down the rate that the fuel vapour is coming off. And given that it's the vapour that's burning, in that way we can sustain the amount of time that it's burning for. The smallest detonation that we can show you is that that's produced by an electric detonator or a single detonator, which is the first and smallest explosive component in any device. The ones that we're using today are number 8 star detonators, which are commercial detonators. They've got about 1.4 grams of high explosive. So again, to visualise that, it's about the size of a couple of garden peas. To show you the power of it, we've got it positioned inside a military steel ammunition container. What we're going to do now is fire off a short length of detonating cord. The most common explosive weight for detonating cord is about 10 grams of explosive per metre length. We've got about 4 or 5 metres of detonating cord at about 10 grams per metre, so we're looking at about 40 to 50 grams of high explosive. Remember, when a high explosive detonates, it is a shock wave that progresses through the thing as it decomposes. That shock wave is going to start from the left-hand side as you're looking, which is where the detonator is attached to it, and it's going to move across to the right, and it's going to do so at about 7 kilometres per second. What we're going to do now is actually do a side-by-side comparison of the effect of a homemade explosive versus a properly produced plastic type explosive. So what we're going to do is fire homemade explosive first, and this is a mixture of ammonium nitrate and aluminium powder. The weight, incidentally, is 227 grams. The charge on the right is 227 grams of plastic explosive. That's our military plastic explosive. It's called PE4, plastic explosive number 4, and it contains 88% by weight of RDX. The rest of it is wax, and the wax is there to desensitize it, to make it safe to handle and store and stuff like that, and also to make it waxy and mouldable, like putty, so that it can be pressed into things and moulded into shapes and stuff like that. We're going to fire a simulated letter bomb containing 60 grams. Okay, the largest letter bomb encountered in this country is about 120 grams, and we're using sheet explosive. Our sheet explosive comes about 3 millimetres thick, so it's ideal for letter bombs and stuff like that because it's easily lost inside a padded mail bag or a book or something like that. So 60 grams on a desktop. Bear in mind we're in the big outdoors, lots of space for the blast and effects to dissipate into. In the confines of a building you get reflections and amplifications of blast wave and the effect will be worse. The final demonstration is a blast incendiary. Okay, and as the name suggests, it combines the blast effect produced by a detonating explosive with an incendiary effect, which in this case is produced by burning petrol. 1.5 litre drinks bottle in this case, it's containing petrol. Attached to the side is about 50 odd grams of plastic explosive wrapped in tin foil. What's going to happen is that a charge will detonate and the blast will project that petrol into a big cloud. Once it's mixed with atmospheric oxygen, it will then burn.
Explosive devices come in all shapes and sizes, and here we've just got a small sample. If we look at these cassette incendiaries, both the low explosive and the high explosive versions that can be left on aircraft. Small little time and power units that can contain about 50 grams of high explosive in there as a donor charge or trigger charge or a charge in its own right. We have various pipe bombs which have been used by Palestinian suicide bombers to increase fragmentation, and various pieces of military ordnance, hand grenades, etc.
As we've seen, explosive and incendiary devices can take many forms and be concealed in a great variety of containers. The key to identifying them is an awareness of their component parts and constant vigilance when screening or searching passengers or their baggage. If you suspect something or are in any doubt that you've discovered an improvised explosive or incendiary device, do not disturb it. Call your supervisor, who will call the police, who will take charge of the situation.